welcome to another AQA chemistry video. Today I'm going to be doing a video on collision theory. So this is now on the kinetics topic. Alright, so let's get straight into it. So collision theory is the theory that explains how reactions happen. When will a reaction happen? So for example, for a reaction between two molecules to happen, they must come into close proximity of each other. And for a particular reaction to happen, several conditions must be met. So the correct part of the molecule must collide, which is known as the steric factor, and the molecules must collide with enough energy to react, which is the activation energy. So this is something that you probably covered in GCSE, you should have covered in GCSE, but just understanding physically how the reaction is actually happening and what conditions that need to be met, or what things need to happen in order for the reaction to happen, and why just because two particles are necessarily in the same jar as one another or in the same beakers on another, it doesn't necessarily, and they collide, just because they're colliding on another doesn't necessarily mean that they're reacting. There's certain conditions that need to be met, right? So the first factor is the steric factor. The steric factor is just another name of it for just saying the location of a collision, explaining why the location of the collision matters, right? So the correct part of the molecule needs to collide with the correct part of another molecule. So for example, if you're trying to react a hydroxide bond in ethanol, for example, which is as shown there, CH3, CH2OH, a collision with a CH3 bond wouldn't do anything if you were trying to react to the OH functional group, right? The OH would need to collide with with the whatever reaction you have, right? So it's important that this part of the molecule, the OH, is the part that's colliding, not the CH3, as in colliding with the other molecule that you're trying to react it with. And the second part, which is arguably the even greater reason, or I say they're both equally as important, right? But the ones that you should definitely know by now is that the activation energy, and the activation energy, well, is the minimum. I'll probably give you the definition is the minimum amount of energy required in order for a reactant to react, or in order for reactants to react. And that's the definition of an activation energy. The minimum is important. Use the word minimum. The minimum amount of energy. I should probably put it down here. Yes. Yeah. The activation energy is the minimum energy needed for a reaction to happen. Yeah, so the activation energy is used to break the bonds in the reactants before new bonds can form in the product. So if you don't have the activation energy, there's not much of that endothermic. Sorry, remember, bond breaking is endothermic, and in order for the reaction to happen, you have to break bonds before you form new ones. And if you don't meet the activation energy, you haven't got the minimum energy required to break the bonds that are in your reactants in order to for the reactions to reform, to form new bonds to form your product. So that's another reason. So for both of these reasons of activation energy and steric factor, most collisions don't result in the reaction. So if they don't have the right steric factor, they don't collide in a certain way, and if they don't have the minimum required energy to react, i.e. the activation energy, then they can collide with one another, but they don't have the activation energy or the steric factor to react, and therefore there's no actual reaction happening. It's just it hits and it kind of rebounds over one another. So here's an enthalpy profile, right? This is clearly an endothermic reaction. Yeah, so enthalpy profiles show the progress of reaction on the x-axis and the energy level on the y-axis. So you should know this from GCSE. And they contain the following information: the relative enthalpies of reactants and products, so the relative enthalpies of the reactants and the products. The activation energy of the reaction is from the difference between the reactants to the maximum peak, that's the activation energy. And then the overall enthalpy change of a reaction is the difference between the enthalpy between the reactants and the products. So if it's in, and this is a perfect way of showing you that endothermic reactions is positive, because if it was an exothermic reaction, right, the reactants would have higher energy than the products, and therefore you get a negative enthalpy change. This is showing you a positive enthalpy change. And this diagram in particular is an endothermic reaction. So the main things you need to understand for the collision theory is that in order for reactants for two reactants to react, they must collide with a specific. They must collide. They must collide in a particular way so that they meet the steric factor. They have to collide in a particular way, and they must collide with the sufficient activation energy in order for the two reactants to react. And that's it.